Recently, I dedicated an entire video to talking about how calcitriol vitamin D was eventually produced after UV rays and photons hit your skin and did a few things, gave energy to 7-dehydrocholesterol. This could turn into this, that, then this could go into the bloodstream, turn into this and that, and then eventually you got calcitriol. Now, calcitriol is said in many studies, in lots of studies, there is a clear association between increased vitamin D and increased testosterone levels. But why exactly does that happen? Vitamin D is involved in the regulation of both the absorption and the excretion, as well as the sort of general homeostasis of calcium. That's one of the main things that it actually does inside of the body. That's one of calcitriol's big main roles. But seemingly calcitriol can have a few other benefits as well, such as the increase in testosterone. But why on earth does this happen? Because it's clear that its main role is to regulate, help absorb, do this and that to calcium. Why does it suddenly have such an adverse effect, a good effect potentially, on testosterone levels? Now, the first way that vitamin D, calcitriol, can help increase testosterone is through regulation of gene expression and helping in the protein synthesis of these certain genes. Now, the enzymes that are needed to catalyze reactions from cholesterol, which is the sort of building block of all of the steroid hormones, enzymes are needed to transfer cholesterol all the way into things like progesterone, things like DHEA, all that stuff. This will then end up going to the testosterone. Some of the enzymes that are needed in these pathways are regulated and their expression is helped by calcitriol's existence. For instance, CYP11A1. The CYP part of this enzyme stands for cytochrome P450. That's the class, that's the category of enzyme. And then the 11A1, that's sort of the specific enzyme that this actually is. Vitamin D helps to mean that this enzyme can actually be produced inside of certain cells. And this means that more cholesterol, this is what the enzyme actually does. Cholesterol can be converted into pregnenolone. That's the reaction that this enzyme actually catalyzes, and so you get more of that reaction happening. Therefore, it's more likely that more testosterone is going to be produced if you have more of these enzymes being expressed and being produced via protein synthesis, via just general sort of bodily anatomy functions. Another enzyme that is influenced by vitamin D is CYP17A1. And this enzyme, again, cytochrome P450, converts pregnenolone into DHEA. Now, this is actually a two-step thing. Pregnenolone doesn't exactly convert straight into DHEA, but in the steps that it does end up converting, this enzyme is eventually needed and eventually used to transfer certain atoms and molecules, etc. And that means that if there's more DHEA, there can eventually be more testosterone, as this is an even closer precursor, as in DHEA is even closer than cholesterol in chemical structure and in the sort of steroid hormone production pathway to testosterone than cholesterol to pregnenolone is. This is like another step up inside of the pathway. And the third enzyme is an HSD3B1 enzyme. The D stands for dehydrogenase. This isn't a cytochrome P450. This is a dehydrogenase enzyme, meaning it's going to get rid of 2 hydrogens, probably. And then that means that the chemical structure is going to change ever so slightly. And this specific enzyme catalyzes the reaction of pregnenolone, such a mouthful, it's so annoying, to progesterone, which is also, again, a precursor to not only testosterone, but it can be converted into things like cortisol, which are also very vital hormones. Now, how on earth does vitamin D actually help to regulate the expressions of these genes? How on earth does it actually help the protein synthesis of these specific enzymes through the sort of nitrogenous bases, etc.? And this is because of VDRs that are present on many cells, including cells inside of the testes, which means that these reactions can sort of end up happening later down the line when vitamin D binds the vitamin D protein receptor. This can cause a set of chemical reactions, signaling reactions to happen, which may indirectly affect the way that these genes are expressed and synthesized inside of cells, ribosomes, etc. And another way that vitamin D can help increase testosterone is if vitamin D levels are high, parathyroid hormone levels are likely to be low, because parathyroid hormone is involved in the negative feedback loop of calcium, as vitamin D3 is, because parathyroid hormone can help increase calcidiol production into calcitriol production, But if there is enough calcitriol already from the diet, you have enough calcitriol circulating around your bloodstream, then that means that there's no need for parathyroid hormone. But if calcium ion levels are still low, parathyroid hormone, it will obviously still try to increase calcidiol calcitriol to balance calcium Ca2 plus ion levels, but it will also take calcium ions out of literal bones inside of your body into the bloodstream to help regulate calcium ion baseline level. If calcitriol isn't doing enough, that's what parathyroid hormone will do, and that will in turn decrease testosterone levels, because if you have extremely weak bones from parathyroid hormone taking calcium out of the bones, this means that it's going to disrupt your entire endocrine system, including how testosterone is produced. Bit of an indirect effect, because these weak bones will help screw up pretty much all of the endocrine systems in your body, but this one is also affected as well. If you have enough calcitriol inside of your bloodstream, if you have enough vitamin D in your bloodstream, there is no need for PTH to be released to balance calcium levels, because vitamin D3 is doing that job. Because obviously PTH turns calcidiol into calcitriol. This means that there is more vitamin D, and so calcium levels can sort of return to normal in a way. But if you have good vitamin D, you're going to have good calcium levels. This means PTH doesn't need to take any calcium out of the bones. This means your bones are stronger. This means that testosterone can stay normal. This means that your entire endocrine system can stay normal, because even the slightest smidgen of low calcium and calcitriol not acting enough, it's going to take a bit of calcium out of the bones. That's still going to have a small effect on your testosterone, as well as your entire endocrine system. But as well as high PTH potentially being a cause of low testosterone, high PTH can be actually a marker of low testosterone. If there is high PTH in the bloodstream, obviously it means that calcium ion levels are low. Calcium ions are involved inside of the production of certain enzymes that is needed for testosterone production in certain steroid pathways, the production from cholesterol to testosterone. Calcium may be needed inside of the protein synthesis, the production of these enzymes, the way these enzymes actually even act on the molecules. Calcium is needed somewhere down the line. And so if there are low calcium levels, there are likely to also be low testosterone levels, and this means high PTH levels, and that can be like a marker. If there are low calcium levels, there are low testosterone levels, that means there's high PTH, so you can sort of make a bit of an association between the two. If there's high PTH, there's also probably going to be low vitamin D, so you can sort of low testosterone, low vitamin D, you can make that association as well. But with that, that's pretty much all. That is how testosterone can be affected and increased by vitamin D, calcitriol. So with that, I hope you enjoyed, and I recommend subscribing, because I love this community of young tribal people who are willing to improve themselves so much more than they already have, and good luck.